Hello, welcome to In 5 Minutes. Next is PNP transistor given. So we can identify again, even if it is given in the question, by the diagram. Arrow is always pointing from P to N. So this is PNP transistor, right? Now you can again identify the base, emitter and collector. You can say this is base resistance. So base, this is emitter, and this point is your collector. Now we can again find the current flowing through the circuit. How you can identify the current? This is collector, this is emitter. Direction is from P to N. So emitter current will flow inside, base current will flow in this direction, and collector current will flow in this direction. Now as we have identified everything, we need to find the value of RC to obtain VC as plus 5 volts. This value you need to get it as 5 volts. Then what we can do, in order to find the value of RC, we need to know the current flowing through RC, because VC if you know and you apply KVL in this, if you know the value of current, you can find the value of RC. So for that, what we can do, we can apply KVL say in this loop. So when you are applying KVL over here, what will be the equation? You can say KVL to base emitter loop. Applying KVL to base emitter loop, your equation will be, you are living with a positive sign, so positive, negative, it is grounded. So you can say 10, this is plus minus VEB. So again write minus VEB. VEB active and VEB on, both are same thing. So VEB on minus IB RB. Why minus? Positive, we are living with negative sign. So minus IB RB equals to 0. So from this you can find the value of IB as 10 minus 0.7 whole divided by 100 into 10 raised to 3. So this will give you IB as 93 microampere. Once you have found the value of IB, you can find the value of IC. How you are finding the value of IC? IC is nothing but beta times IB. Beta is given as 50 in the question. So 50 into 93 microampere will give you the value of IC, which is 4.65 milliampere. Once you know the value of IC, now what I will do, I will apply KVL in this loop. You have the resistor, you have plus VC, this is grounded. So this is your resistance RC plus VC. You are applying KVL from this point to ground. So when you are applying KVL over here, your equation will be VC, which is 5 volts. Connection, we are living with positive sign, so it will be negative side grounded. So 5, IC is flowing upward, so positive, negative, we are living with negative sign, so minus IC into RC equals to 0. So we can write 5 is equal to IC into RC. We need to find the value of RC. So RC will be 5 divided by IC. IC we have found at 4.65 milliampere. So we will get RC as 1.0752 kilo ohms. This is how we have designed the circuit for the question given as to design RC. Now the second part of the question, what if the transistor is replaced with another transistor having beta 100? What is the effect of changing the value of beta on RC? So again, with beta equals to 100, we need to do all the calculations. We have already done the calculation with beta 50. So with beta 100, you will get, what will change? With beta 100, your IC will change. Instead of 4.65, you will get IC as 9.3 milliampere. So once you have got IC, your equation in this loop was VC minus IC RC equals to 0. That is, RC was VC upon IC. VC is constant 5 volts and IC is now 9.3 into 10 raised to minus 3. So what is the value of resistance? 537.6 ohms. So what you can say, as the value of beta is increasing, the value of resistance which is required to produce same amount of current is decreasing. That means as beta value changes, what you can just try this, when beta changes, your resistance changes. When beta increases, the resistance value decreases. When beta is increasing, your resistance is decreasing.